Hi everyone, welcome to this video. My name is Phil and I'm a senior lecturer in astrophysics at the University of Lincoln. And in this video, I want to go back to exoplanets. And this time around, we're looking for the most distant exoplanet we've discovered so far. I'm going to explain which planet that is. Actually, to be honest, it's actually two, which I've kind of got up here, but also how they were detected and what type of planet they actually are. So just to kind of recap what an exoplanet is, if we look at our solar system, then the planets in our solar system orbit the sun. But an exoplanet is actually a planet that orbits around a star other than our sun. So we call that exo for extrasolar. So exoplanets are outside of the solar system, and we've discovered thousands and thousands of those, all with different properties, different distances. So now we're going to have a look at what the most distant one is. So it's actually two. So two of these are actually at a very similar distance. So we've got SWEEPS-4b, which is the top one, and we've got SWEEPS-11b, which is the bottom one. They're slightly different sizes, but roughly the same sort of distance away from the Earth, which is about 8,500 parsecs. Now that might seem like not necessarily an odd number, but a hard number to kind of put into context. So just as an example, this is the Milky Way. I've kind of highlighted where we are on the Milky Way. We're located approximately, a similar sort of distance from the center of our galaxy to how far away these planets are. So about 8,000, well, we're actually, 7 to 8,000 parsecs from the center of the Milky Way. These planets are about 8,500 parsecs. So we're roughly the same sort of distance as we are from the center of the Milky Way. So size comparison. What sort of size or type of planets are they? Well, in comparison to Jupiter, they're fairly similar. So the first one, SWEEPS-4b, is slightly smaller than Jupiter in mass. So it's about 0.81 Jupiter masses. And SWEEPS-11b is a little bit bigger, so it's about a third more massive, so about 1.33 Jupiter masses. They orbit two separate stars, obviously, because SWEEPS-11 and SWEEPS-4 are actually the host star. The lowercase b denotes it's the first planet discovered around that particular star. So SWEEPS-11b they've both got very short orbital periods, and AU is essentially their orbital radius, their semi-major axis. So SWEEPS-11b is located about 0.055 AU from its star, and then SWEEPS-4b is slightly closer at 0.03 AU, where AU is one astronomical unit. So if we had one astronomical unit, that's the average distance between the Earth and the Sun. So you can see that these are only a few percent the distance between the Earth and the Sun, so very close to their particular stars. So very short orbital periods because of that. So if you have a very small semi-major axis orbital radius, you're going to have a short orbital period because there's less to go around. You also have a faster orbital velocity. So SWEEPS-11b is just under 1.8 days to go around its star. And that's obviously a very short orbital period. And then you've got SWEEPS-4b, which is just over 4 days, so 4.2 days to go around its particular star. Now, they both orbit low mass main sequence stars, so reasonably similar to the Sun, although we don't have a huge amount of detail about them because they are so far away. We don't have a full complement of parameters for the stars and the planets, just a few bits of information. So SWEEPS-4b is orbiting a star that's at about 1.1 solar masses, and SWEEPS-11b is orbiting one about 1.24 solar masses. So we would classify those as low mass main sequence stars. So that means that they're basically going to probably be hot Jupiters because they're very close to their star, very, very close, much closer than Earth is. They're obviously Jupiter sort of size, so we would call those hot Jupiters. So temperature-wise, you're looking at the high end of hundreds into thousands of Kelvin. We don't have a temperature for them. but as an approximation, given their distance to the actual star and their size, we will most likely definitely classify these as hot Jupiters. So how were they actually detected? Well, they were detected using the transit method. So the transit method is when a planet passes in front of its star and it blocks out some of the light. What that does is we get this transit, so we get this dip in the brightness, which you can see kind of on the right there. So if we measure the brightness of the star, it will stay constant, assuming it's not a variable star. And then as soon as the planet goes in front, it blocks some of that light out until it passes over the other side. Obviously, it has to be aligned correctly so it goes in front of the star, line of sight to us. But this is the method that was used to detect both of these planets. So I've got some examples of the actual data here. So this is SWEEPS-4b, and I've highlighted in the green box on the right the actual transit, and you can see it's actually quite weak. I guess that's to be expected, really, given how far away it is. Thank you for watching. If you enjoyed the video, then do consider becoming a member of the channel. There's extra videos in the member section, but it also helps support the channel. So thank you for watching.